Alright, so this video is for practicing using the normal model. So let's look at the questions. It says using the normal model to analyze points per game. So what are the mean and standard deviation of the variable points per game? So we're going to go to the spreadsheet. Let's find points per game. So that's M. Let me just copy and paste this into a new sheet just for fun. Alright, so the mean is the average, so equals average, and then I'll select all of this. So the mean is 16.259, and standard deviation equals STDEV of all of this. All right, so we have a mean, we'll call it 16.3. We'll round, and then we'll say standard deviation is 4.95. So mean equals 16.3. Standard deviation equals, what do we say, 4.95. All right, so we have a mean and standard deviation. Assuming a normal model, 99.7% of players should play between how many minutes? So if we use our 68, 95, 99.7 rule, let me do a little drawing here, or I'll do lines. So between 1 standard deviation plus or minus the mean. So if this is the mean is, what should I write? I'll write in red, 16.3. So if I go plus 1 standard deviation to minus 1 standard deviation, 68% of the data should fall between these kind of boundaries. So this is 68%. So 68% of the data is in this purple range here. This whole purple range. All right, so 95% of the data will be plus or minus 2 standard deviations. So if I go to 2, should have made that black. That's fine. So if I go plus or minus 2 standard deviations, 95% of the data should be in this range. So this is plus 2 standard deviations. This is minus 2 standard deviations. So in this, let's say, green range, should be 95% of the data. 95%. We'll say 95% should be in green. 99.7 is that third kind of set of boundaries. So plus or minus 3 standard deviations. So I'll go plus 3, minus 3. And we will say plus 3 standard deviations, minus 3 standard deviations. So in this range, we'll say the orange range. In this orange range, I'll draw it like up here. So in this orange range, should be 99.7% of the data. So 99.7 in the orange. So the question asks, so I go back to the question, it asks 99.7 players should be between how many minutes? So if I start at the mean, of 16.3, I can add 3 standard deviations onto that to find my upper bound. So my mean is 16.3 plus 3 times the standard deviation. So that's going to be my upper bound is 31.15. So this value here is 31.15. And the low value, I would just subtract 3 standard deviations from the mean. So 16.3 minus 3 times the standard deviation, which is 4.95. So that gives me 1.45. So 1.45, 1.45. So 99.7% of players should score between 1.45 points a game and 31.15 points a game. So 1.45 and 31.15 points per game. So next question says, assuming a normal model, what percentage of players would we expect to score more points than Victor Oladipo? So first we need to find the z-score for Victor Oladipo. Victor for Oladipo. So let's find how many points he scored. So if I go to the data, I will search for Oladipo, and I find him here, and it looks like he scored 23.1 points per game. So Oladipo equals 23.1 points per game. What's his z-score? Well, that's going to be his value minus the mean divided by the standard deviation. So 23.1 minus 16.3 divided by 4.95. So let's calculate that here. Equals, he was, what, 23.1 minus 16.3, and I'll put that in brackets, divided by 4.95. Standard deviation. So his z-score is 1.37. I'll call it 1.37. So what I'm going to do is I need to go to a z-score table. So this is a z-score table. I need to find the z-score of 1.37. So the z-scores all start in this first column, and you'll notice that these are all negatives. My number is positive, so I'm going to go down to the positives, and I'm looking for 1.37. So I'm going to go down to 1.3, and now I need to find the hundredth. So 1.3 is here, but 0.7 is all the way over here. So I need to find where they meet. So 1.3, and I'm going to go all the way to 0.7. So they meet here. So this number represents the shaded area up here. So this number represents the shaded area, and the number says 0.9147. So if I go to Paint and I want to draw this, I would say, okay, Victor Oladipo is this green line, and he is 1.37 standard deviations above. So what I'm saying is that the shaded area, this green shaded area, all of this, what's less than him is the number that I got from that table. So 0.9147, 0.9147, that's the same as saying 91.47%. So 91.47% of players should score less than Victor Oladipo. What does the question ask? What percentage of players would we expect to score more? So more would be 1 minus 0.9147. So what is 1 minus 0.9147? Oops, I'll put it equals. And it gives me 0.0853. So if I write this as a percent, 0.0853, that would be 8.53% should score more than Oladipo. Right, because if 91.47% should score less, then the rest will score more, 8.53%. So let's jump to the next question. Assuming a normal model, what percentage of players should we expect to score fewer minutes than CJ McCollum, but more than Dario Saric? So fewer than McCollum, more than Saric. Let me split this into a second video just in the interest of time.